On the following equations, right, all these are representatives. These all represent the equation f of x equals a by b to the power of x. Now guys, for example, this would mean, first example would be a is bigger than 0, b is bigger than 1. So our example would be a could be 2, b could be the number 3, and it's the power of x. Now, we put this into a graph function, okay, and look what happens. Or into our table function, okay? What we'll get is f of x equals 2 by 3 to the power of x. And we'll start at a minus number. Let's go from minus 4 all the way to plus 5. Just give it an accurate representation. Now guys, look at this. Minus 4 starts off really small. Do you understand? Minus 4 is really small. Minus 3 is bigger. Minus 2 is bigger. Minus 1 getting bigger again. 2, 0, 2, 1, 6, 2, 18, 3, 54. So do you understand? Small differences at the start, large differences at the end, causing it to curve upwards. Now let me explain this. 3 to the power of 2 to the minus 2 times 3 to the power of minus 2, let's say. That's 2 times a ninth, which is 2 ninths. 2 times 3 to the power of minus 1, 2 times a third, which is 2 thirds. 2 times 3 to the power of 0, 2. 2 times 3 to the power of 1, what is it? 6. 2 times 3 to the power of 2, 18. So basically you can see that if I was to mark this out, that's 0, that'll be 1, that's 2. You can see that the graph is increasing very quickly because A is a positive number and B is a positive number. Does everybody get that? If you're drawing that, the reason for this is, the reason why I put down A equals 2 is, was asked for any number that's bigger than 0 and B is any number bigger than 1. And I chose this equation to represent diagram 1. Okay? The next thing I'm going to do is show you an equation to represent diagram 2. Now diagram 2 states that A is bigger than 0. So that means so that's a b to the x. So A, I'll pick a number bigger than 0. I'll pick the number 5. Okay? Any number bigger than 0. Okay? So I pick number 5. B is any fraction. Do you understand? Any positive fraction. It has to be in between 0 and 1. And what you'll see here is I'll pick a half. Okay? Once again, I'll go to my calculator. I'll put this in. And I'll say 5. And then I'll say this is the power of a half. Now, the interesting thing to notice about a half is the more you power a half, the smaller it gets. So for example, if you power a half to the power of 1 is a half. A half to the power of 2, a quarter. A half to the power, I don't know, 4 is 1 over 16. It gets smaller and smaller and smaller as the x value gets bigger. So look what happens in the tables. It starts off at 80. So at minus 4 it's at 80. It's up here. Minus 3 it's at 40. Minus 2 it's at 20. Minus 1 it's at 10. 0 it's at 5. And then after it crosses, it gets smaller, 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 smaller. It will get very close to 0, but will never ever reach 0. Can anybody tell me why? It's a tiny fraction. It's a half of a half of a half of a half of a half. You never get 0 by halving things. You just get a really, really small number. Okay? So that's why it never crosses the x-axis. So when this happens, the function is decreasing. The next one, which is number 3, which I'll haul up here. Okay? When A is smaller than 0 and B is bigger than 1. Example, A is minus 3, B is any number bigger than 1. I'll go for 2. Minus 3 by 2 to the power of x. Now look at this. Okay, once again into the calculator function. Minus 3 bracket 2 to the power of x. 2 to the power of x. Once again go from minus 4 to 5. Look what happens this time. Starts off close to the x-axis in the negative part. and then becomes more and more and more negative. This goes, it starts off close to the x-axis, and then as x gets bigger, it gets more and more and more negative. Everybody happy with that?
Yes.
Okay, and then finally, the last one is where a is negative, where a is negative and b is a fraction. So an example of this one would be minus 3 to the power of a half x. You have enough of that? So, what happens here this time around is that we'll get a minus 3 bracket 2 to the power of x, and then minus 4 to 5, once again step 1, and then you'll see that it goes from minus 4, and it's getting more and more. Wait a second. A half, excuse me. I did that one wrong there. Let's go again. It's starting off really negative. Simon, can you see that it's starting off really negative at minus 48? And then you can see that it just keeps going upwards. But it never ever crosses the x-axis. It's always going to be underneath. Now to check this out, guys, what I could do is this. I could make my limits even further. Let's do an end of 20. Okay? Now look at this. An end of 20. Now look what happens as x gets bigger. As x gets bigger, look what happens to the number. What's happening to it? Sorry guys, do you know what that is? It can't fit the number in. It's actually getting smaller and smaller and smaller. It's getting smaller than 0.01. It has to get closer and closer and closer, even though the calculator is not saying that. It has to get closer and closer and closer. Alright guys, now what happened for homework tonight, we're going to do the 1, 3, 5, 6 and 7. 1, 3, 5, 6, 7, 8. Now guys, you just draw the graphs. You put them into the calculator, you draw the graphs. Upon drawing your graph, okay, so for example this one here, from your graph right down the point of intersection. On this one here you have to draw the graph, and then you have to draw a line, and then you have to see where they both intersect each other. Okay? And then you have to find the values which are bigger than minus 2 for which the curve is bigger than the line. Okay? So 1, 3, 5, 7, 8. So what's it? 1, 3, 5, 6, 7, 8.